How are you?
Good.
Good seeing you here.
Yeah.
That's so funny. All right. I thought you still had some hours left, so I wasn't sure.
Yeah, it's because I'm gonna get biology tutoring because I have like a genetics class that's like killing me. So
Oh,
if I don't use my hours on chem.
I see. Okay, sounds good. All right, do you want to share your screen or what do you want to do? Oh, wait. Why am I not sharing my screen?
Yeah, you are.
Yeah.
I feel like you're one.
Oh, you want to share your screen or how do you want to do this?
Okay, I'll probably share my screen. Let me see.
Okay, then I'll stop sharing. Give me a second.
Oh, I think you have to. Okay, yeah, I know. You're good.
Yeah. So you're taking genetics?
Yeah, it's not fun.
Is it Mendelian genetics or is it like
Yeah, we're doing Mendel right now.
mm, how fun? I you just have to memorize
Yeah, I don't
the
know.
stupid formulas
Yeah,
and the ratios. I am so glad I don't have to do that ever again.
yeah, I'm taking it honors too, so it's it's so bad.
So how was your quiz test?
In chem,
Yeah,
oh, I did pretty well.
good, good. After cheating.
Speaking of cheating, okay, I got I got the answers from my friend, but probably try to do some of these. Like this one.
I'll just annotate on the screen.
Oh, okay.
I think that would just be easier. And then I can upload it onto YouTube and then send you the link.
Oh, okay.
Unless you don't want to. It's extra
No,
work for me.
no, it's good because sometimes I go back and look at them.
Okay, cool, cool.
Wait, actually, I think I can just record the meeting. I think.
Yeah, it's recording on my end. I think you can record it on your end too.
Okay, I think you have to give me like recording permission.
Yeah, I'll send you the recording. No big deal. No big deal. I mean, I'll upload it onto YouTube just because it is a very large file.
Oh, okay.
Yeah, and I'll send you the link.
Okay.
Yeah, I mean, who knows me on YouTube? So it's not like anyone else is gonna watch it. Okay, so this one you do have to use the lambda C equals lambda V, or yep, that's a de Broglie's. This right here is you just have to memorize that equation.
What is de Broglie? Is it that equation?
That is the equation, yeah. I know. That's de Broglie.
Okay.
So it's like basically solving the wavelength of a moving electron.
Okay.
Yeah. And they gave you the wavelength, which is 1.4. So that's lambda. And then H is Planck's constant, which is, you already have it. And then M is mass and V is the velocity.
Okay.
But the mass is usually going to be, yeah. So the mass, they're going to give it to you as, well, the equation itself is going to be in kilograms because of the joules. So if they give you the mass in grams, you have to switch it to kilograms. Does that make sense?
You have to switch for meters. Do you keep it in meters?
Yeah, you can keep it in meters because here, this is what I'm trying to tell you. What I'm trying to tell you is this is speed. This is V, right? This is speed. But do you see how this is Planck's constant and 6.62 times 10 to the negative 34 joule seconds? Because of joules, your mass is going to be, or that is going to be in kilograms.
Okay.
Okay, that's all they're saying. So if they give you in grams, you switch it to kilograms.
But only if it's in joules.
For this particular equation, because H is Planck's constant, which is joules.
Oh, okay.
Yeah, Planck's constant units is joule seconds.
Whenever you use H.
Whenever you use H, you have to use kilograms if you need to do mass.
Okay. So how do you know that's the mass of one atom?
That one they have to give it to you,
Wait.
or you're solving for it.
Yeah, it's because how do you know to do that? Because I would have just put that as the answer. Like, how do you know that it's one atom and you have to use like Avogadro's number?
Because what do you mean? Because that is the equation. The mass for the Broglie's equation is for one atom.
For one atom? Oh, okay.
Yeah,
So you always use Avogadro's number?
yeah, for moles. If you want, they want a molar mass, and molar mass is grams per mole.
Okay.
But the mass in de Broglie's equation is only for one.
Oh, okay.
Yeah.
And
Whoever your friend is so smart.
yeah, it really is. Do you always use 1,000 grams?
For kilograms. To switch, yeah, because molar mass is, okay, molar mass is always grams per mole. These are the units for molar mass. Okay, in de Broglie's, it's this, right? Lambda is actually always going to be in nanometers, but you can always switch it to meters. Okay, joules, here, let me do it with a different color.
Wait, so do you always switch nanometers to meters?
When you're doing calculations,
That's divide by 10 to the ninth? Or how do you do that?
yeah,
Okay.
yeah, one meter, no, 10 to the negative 9 meters is 1 nanometer. Yeah?
Yeah.
Okay. And Planck's constant is always joules second. This is always going to be in kilograms, and this is always going to be meters per second. Because velocity is always meters per second, you have to change nanometers to meters.
Oh, okay.
And I believe joules is like kilograms per temperature or something like that.
Okay.
Joules units to, it's like kilograms, meters, and seconds. Joules is kilograms. 1 joule is always kilograms, meters. Oh wow, it won't let me write. Joules is always kilograms, meters squared, second squared. That's why.
Oh, okay. So it's in kilograms and meters.
Yeah. Because joules, if you were to break down joules, it's always kilograms, meters squared, second squared. That's what you got to do.
Okay. For this, do you just memorize?
Uh, so this one, there's a way for you to do it. So you do have to know quantum number N, L, ML, and MS. Do you remember these?
L is like where it is. How come they don't do like 1s2, like 2s2?
So
Like
that's
they,
electron configuration.
okay, so this L tells you if it's like P, S, F, whatever.
Yeah, this is going to be the orbital shape.
Oh, actually, shit, hold on, let me just look up a P. For the N values, there's one that's like, that like skips it. Like what N is this? No?
That's N equals 3.
This is 3?
Yeah,
Okay, so it's 4, 5, 6. What about this?
that's 4.
This
So
is,
here, let me show you. Can I share my screen for a sec? Can you see my screen?
wait, hold on. Yeah.
Basically, this right here is first floor, right? Assuming this is the nucleus, right? This is the first shell. We call this N equals 1, okay, first shell. And the orbital is an s orbital, okay? This right here is the second shell, so this is N equals 1, this is N equals 2. So second shell, right? This is N equals 2, right? It's s orbital. Now, if you look at it, s orbital is 1, 2 electrons. Do you see that?
Yeah.
And then you have p orbitals, right? 1, 2, 3. So there's 3 different directions that the p orbitals would orbit.
Yeah.
Okay, so these are p orbitals, but it's like py, px, and pz, right?
Yeah.
So p orbitals, they have 3 directions, and each one can hold up to 2 electrons, right? So 1, 2, 3, 4, 5, 6. Do you see? Okay.
Yeah.
And then you continue to third floor. This is N equals 3. So third floor, you have this, right? So again,
Yeah.
s orbital, so that's N equals 3. And then you have p orbitals again, 1, 2, 3. So again, you have 1, 2, and then 1, 2, 3, 4, 5, 6. So again, you have 8 orbitals on third floor, right? Okay. So now you go on to fourth floor. So fourth floor, you create the s orbital. But then you look down and you're like, wait a minute. Second and third floor, they have the same number of electrons, but the third floor is wider and bigger than the fourth floor, right? Do you see how every time we go out, it becomes bigger and bigger and bigger in surface area? But do
Yeah.
you see how second floor only has 8 electrons? Third floor also has 8 electrons? They have same number of electrons, so they're like, what the heck? We have more space on the third floor than the second. So then they
Wait,
decide that,
the second is the blue one, like starting with B, and also the pink ones on the left.
say that again?
The second floor is starting with these pink ones, the pink lines on the, I think it's lithium or something.
So the pink line would have already started here. This is also pink,
Oh, okay, but that's the
right?
first. That's the first floor. It only has
This
2.
is first floor, second floor, third floor, fourth floor. Do you see?
Wait, how is the fourth floor wider? Is it because of that gap in the middle on the third floor?
So this is fourth floor right here,
The whole thing.
the whole thing. Now, what happens is though, we look at third and second and they have the same number of electrons. So they're like, wait a minute, they have the same number of electrons. We don't like that. We can squeeze more into the third floor.
Oh,
So this becomes internal. So this is third floor. So it dips down.
okay.
Make sense? And then we go back up to fourth floor. Okay, so when we dip down to the third floor, we now are going to have d orbitals, and the d orbitals, they look like this. And there's 5 different directions. Okay, d orbitals, and there's 5 directions. This is why if you look, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 electrons in the d orbitals. So that gets put in here. Does that make sense?
Yeah.
Third floor. Okay, it's kind of like an upside down pyramid, right? Where as you go up, you start putting more rooms.
Oh, okay.
Yeah. And then they're like, wait, now we have to pop back up to the fourth floor, right? But this one is on the fourth floor like this. Do you see?
Oh, okay.
Does that kind of make sense?
Yeah, so because there's more room, like, because there's still extra room, like on the second and third.
Correct. So this is 5, 6, 7. This is 3, 4, 5, 6. Do you see that? 4, 5, 6. Do you see that?
Yeah. How come they don't? How come they just don't put it there?
I don't know. I didn't create the freaking periodic table. So then what happens is, do you see how we have number 56 and then 57 and then 72?
Yeah.
Okay, so after 56, I know it says 57 right there, but we actually go down here. After 57, we go down here.
Wait. So
So
what number is that again? The lanthanides?
the lanthanides, they start at 58.
But what floor is it?
So yeah, so then from here, we actually go back down to floor 4. So we finish floor 4, and then we come back up. And then we finish 5, go to 6, and then 7. And then from here, we go down again, and so this is 5.
So for n numbers, then that's n equals 4.
Correct.
Okay.
Does that kind of make sense?
Yeah, kind of.
Okay. So here's the thing. Let me just redraw it out for you. I know it looks really messy. And also the F, this is F block right here. Okay, that's F block. So let me just draw it out for you one more time. Just give me a second. Okay, so if you look at this, all of these are s orbitals. Okay? All of these are p orbitals. Okay? And then all of these are d orbitals. And then down here is F. Okay? Now, if you start counting, this is floor 1, 2, 3, 4, 5, 6, 7, right? This one dips down, so it's 3, 4, 5, 6. This is 1, 2, 3, 4, 5, 6, and this is 4, 5. That makes sense?
Yeah.
And we fill S, P, D, F, G, and so on and so forth.
Wait, what's G?
It keeps going. So the periodic table actually doesn't actually stop here. But you don't have to know this.
Okay.
Just know that it doesn't stop here.
Okay.
Okay? So it's like smart people done first.
Oh.
Got it? S, P, D, F, and then G, H, 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 I, J, K, L, M, N, O, P, and now here's the thing. At school, they will teach it to you as one is to the diagonal rule. You've probably seen this.
Yeah.
Okay, and you always fill 1s first, right? If you look at it, you just fill this 1s, 2s, which is right here, 2p, 4s, 2p, 3s, right? 3p, 4s, 3p, 4s. Do you see? So you're
Yeah.
filling it in that order.
Yeah.
Okay, so 3D, 4P, 5S. And it keeps going. Yeah.
Yeah.
4D, 5P, 6S.
Wait,
4D, 5P, 6S. Yeah.
the L and like ML and like P, like all those numbers, is that just a different way of doing? Yeah.
So electron configuration tells you like the address of the electrons, but the electron configuration tells you the energy, and that's quantum. So N is principal shell number, right?
Yeah. That's row number.
This is floor number. Okay. L is orbital shape. Okay. So is it S? Is it P? Is it D? Is it F? And it keeps going, right? But this goes from 0 all the way to n minus 1. Okay. And for easy sake, S is 0, P is 1, D is 2, F is 3, and it keeps going. ML is orbital spin direction. So s orbital is round and spherical, so there's only one direction. P orbital can be this, this, or this. Do you see how it's 3 different ones?
Yeah.
D orbital can be this, this, this. I don't know. I'm making things up here. I don't know enough for this. Do you see how that works?
Yeah.
Yeah.
Can it be exact? Like, can you use it to find out exactly what the element is?
Yes. No. This, no. With quantum numbers, you cannot, because this is just wavelengths. And this goes from negative L all the way to positive L. And the way it works is, if it's 0, is 0. If it's 1, it goes negative 1, 0, positive 1. Do you see?
Yeah.
This is negative 2, negative 1, 0, positive 1, positive 2. Okay? And then ms is spin value. Okay, and the spin value is either positive or negative 1/2, which means, is it spinning up or is it spinning down? That's all it's saying.
Okay.
Got it?
Yeah.
Okay, so for instance, if I say my quantum numbers are 4, 3, negative 5, positive 1/2. Does such a thing exist, yes or no?
Wait, your quantum numbers. So wait, what letter is that?
It's
Oh.
always going to be in that order. Can this exist?
Um,
So if n equals 4, L is going to have to equal 0, 1, 2, or 3,
no.
right? Because ML is going to be 0, negative 1, 0, positive 1, right? Negative
Okay.
2, negative 1, 0, positive 1, positive 2. Negative 3, negative 2, negative 1, 0, positive 1, positive 2, positive 3. Do you see?
Yeah.
So this would never exist. That's it. That's quantum numbers. In a nutshell. Or actually, I should keep it this way. You have to share your screen. Share your screen, sir.
Alright. Oh, I was actually gonna ask you about this one. Um, Oh, wait, actually, no, never mind. So n equals 3 can be in D, right?
Yeah.
Okay. I think these are. Wait, what are the rules for like the possible values again?
What do you mean?
Because I asked like how many values can you are possible when like n equals 5?
It goes from 0 to n minus 1.
L does?
Yes. So it goes here. N can go 0 all the way to infinity. L goes from 1 all the way over to n minus 1.
Oh, okay.
Ah, hold on. What the heck? Backwards. Because you cannot have 0 show. This is 1, this is 0. And then ML is always positive L all the way to negative L. MS is always positive or negative 1/2.
So if they give you S, you just find out like what the if they give you this, you just find out what the L is. And then
They give you,
like 2S is 0L.
correct.
So you can only have like one. Wait, so ML can be negative?
ML
Yeah.
can be negative.
Okay.
Yeah, it goes from negative L to positive L.
Wait, how come it can't be -1 or 1?
What do you mean negative 1 or 1?
Because L is 0.
Yeah.
So plus like
How can you have, if
oh
if L is 0, how can you have a negative
oh,
0?
yeah. I'm
Yeah.
bad at
I think you have to go back to kindergarten. Come on. Okay. So wavelength, that's lambda per photon. Okay. So if they're asking you for energy, what is energy's equation? It's this, right?
Yeah.
But you only have lambda information, right?
Yeah.
You have H information, but you don't have anything else. So then you're going to have to use C equals lambda V. Because then you have this information, you have this information. This is a constant as well.
We convert nanometers to meters.
So this, yep, goes there, and then you solve for E.
Okay. Wait, how do you get the 565? Like the other part?
How did I get the 565? Where is the 565?
There's a second part of the answer.
Oh, because this is for per photon and this is per mole. So you're going to have to do 9.38 times 10 to the negative 22 kilojoules per photon, right?
Yeah.
And then from here, what you're going to do is you're going to multiply it out. 6.02 times 10 to the 23 photons is equal to 1 mole.
To get photons?
Yeah, because it's only for 1 photon, but they want it per mole.
Wait, so a photon is like an atom?
Photon is like a particle of energy, so photon is basically electron.
Oh.
Yeah. Does that make sense?
Yeah. So same thing here.
Yeah. Hold on, I can't see. Give me a second. Yeah. This one, though, they're using watts and seconds. And they're doing it per second. So if they're doing it per second, that just means that is that's in amperes. Let me find the equation for Okay, 1 watt is 1 ampere. It's the same thing. And this is 1 joules per, no. Amperes is 1 coulombs per second. Coulombs is charge. Okay, so 11 joules of energy. So E is 11. Lambda is 1850 nanometers. We have 60 amps. 1 second. What are we looking for? Infrared does a lamp generate in 1 second. How many photons? So we have to figure out joules per photon. Because this is 11 joules of energy. I would just find energy per photon first. So E is equal to lambda V. But this C is equal to lambda V. Lambda is 1850. Uh, 10 to the negative 9, 1. Where's my eraser? So 1.85 times 10 to the negative 6. Oh, I have to find V. So 3 times 10 to the 8 is equal to V, right? And then I plug this into this to find E. So E is equal to is it negative 34? Yeah. So E, I end up with 1.07 times 10 to the negative 19 joules per photon. Okay. But I want to know how much energy is being created this. So then this is what I have. Does this kind of make sense so far?
Yeah, it was just weird 'cause of like the.
What?
It was just weird because of like the photons, but I think it makes sense.
Yeah. And then from here, they're just saying that it's 11. This is joules
Wait, how come they
for
divide?
1 second.
Multiply?
Huh?
How come they divide instead of multiply the 11 joules?
Because they want how many photons? They want how many photons per 1 second. So they want photons per second.
Okay.
And this is how much energy you're creating based on that many nanometers, right?
Yeah.
So if you have that much nanometers, 1.07 times 10 to the negative 19 joules per photon, right? Oh, this light bulb is already like exerting 11 joules per second.
Yeah.
So that's the given, and this is the conversion.
Do you do anything with the 60 watts?
No,
Just check.
because 60 watts later on, if they want to find out, later on, if you do like how many moles of electrons are being um, released or absorbed, that's when you use watts, because you
Okay.
need to use coulombs.
Okay.
Yeah.
Hold on. I'll be right back. I have to use the bathroom.
Okay.
Wait, what are megahertz?
Megahertz, it's per second.
Wait, MHz is per second.
So mega is 10 to the positive 6. Hertz is the same thing as 1 over seconds.
So do I need to convert it, or is it fine like that?
No, because remember when we're doing E is equal to lambda V or anything, or C is equal to, HV or lambda V, right? This is meters per second, right? This
Yeah.
is 1 over seconds. It's not 10 to the 6, so you have to convert this. So if it's 223 megahertz, 223 times 10 to the 6 per second.
Oh, okay. So they multiplied. Oh, okay. Is that it?
Yeah. And then you use that number to do your calculations. So here they're giving you mass, right?
Yeah.
So if they're giving you mass, how much energy would be obtained? Yeah, so the conversion is this: 1 photon over 1 carbon of atom. So every time you have a carbon atom, you're releasing 1 photon, 1 electron. So after you find joules by plugging it into the E equals, actually, do you see how you should memorize this? I should memorize this. This is basically E is equal to HV, C is equal to lambda V, put together, smushed together, and it becomes HC over lambda. Right? So they smushed it together, and after you smushed it, and you know that H and C are constants, also all you need is lambda,
Okay.
right? All you need is lambda. And after you have lambda, you can find E, and that's just joules, right? And then you go from 44 grams to moles of carbon, and then this is moles of photons, and then switch this into just photons, right?
Yeah.
And then you do E over photons, which is basically joules per photons. That's what they mean. Yeah, that one you can do on your own.
Hey, what is this?
Micrometers. What is this? So micrometers is 10 to the negative 6 meters.
Okay.
So do you see how you have this, which is 10 to the positive 6? And then you have this, which is 10 to the negative 6?
Oh. Yeah, they're just using the equals h over lambda a lot.
Yeah, just memorize it. It's just easier.
Is any hard one? Oh, we haven't done one of these.
So this one, all you got to remember is the conversion of voltage, that it's going to be something with joules. That's all I remember. So at least they're nice enough to tell you. The electron voltage, 1 electron voltage is the same thing as that much joules. And the mass of electrons is that much. Okay, so your metal has a work function as light is shattered to the corresponding wavelength. What is the mass of velocity? Oh, they want us to find velocity. Do you remember the equation for velocity? E is equal to, we had it, I think it was question number 1. I think it was this, and V was velocity. I don't remember what this was. I think this is right. Go down. Let me see the formula. Oh, go back up, yeah. Question number 1. What, oh, sorry, maybe 2 or 3. It was on one of the earlier ones.
Oh,
Nope.
it might have been the one we were doing. Wait. Wait, was it this one or the one we were doing earlier?
This is what we were doing earlier. Hold on, let me see. I think it's number 3 or 4 then. No, never mind. It was the earlier question, one of the earlier ones.
Because there was an earlier homework, but that was the one with the like the subshells. But
Oh yeah.
was it
Okay,
on-
let's just go back to your question, the question that we were just working on.
Or is this one?
No, no, it was not this one. We finished this one.
Oh, yeah.
Oh, go back up. Is it this one? Was it this one?
Was
I have to see the question. No, it was like 3.05, not 1.05. Yes, 3.05. So, maximum velocity. Okay. This one. Light is being shined. So I just know that 3.05 E voltages. Yeah, you can switch it using this conversion, right? Switch it to joules. After you switch that to joules, you find the total energy because they're asking you for amount of energy. Okay. If you know energy, right, you can find velocity. And if you find velocity, you can find No, no velocity. Frequency, you can find, you can compare it to light energy. That's what they're doing here. So from here, you go and compare to c, which is speed of light. Okay, because a light is being shined onto the metal.
Okay.
Okay, at wavelength of 524. So remember, E is equal to hc over lambda. So this is a constant, this is a constant, and then here we plug in 524 nanometers, but obviously you would switch that to meters. And I believe that's like 524 nanometers times, that's like 5.24 times 10 to the negative 7 meters. Okay. And then you get joules. Now, if they're saying that if whatever energy you get here, okay, if that is greater than whatever energy 3.05 would be, because you know you have to switch that to joules, right?
Yeah.
So you're comparing this joules to this joules.
To the energy?
These joules to this, yep, because this is also joules, right?
Yeah.
So this
Oh,
is that of the metal,
here?
and this is that of the light that was shined, that was, you know, shining onto it.
And you see which one is bigger?
Correct.
Where does the work function come in? Oh,
This is all work function, yeah.
Okay.
Light can, see, do you see it says like photoelectron produced? Photoelectron will only be produced if the metal, if the metal's energy is larger,
Oh, okay.
right? Because then it can jump out. Metal would be releasing electrons.
Oh, okay.
Are we done? Is that all 10 questions?
We skipped this. We skipped some of them, but they're ones I could do on my own.
Okay. Like plug it in, plug and chug.
Yeah. If real quick for this one, they converted milligrams to moles.
Grams and then to moles.
Okay.
And then to atoms.
Oh, so you have to convert all the way to atoms.
Yeah, and then the atoms are the same thing as photons. And if you have photons, you can multiply it out by the joules to get joules per photon or just joules or whatever it is that they need.
Okay. All right, I think that's good.
Yeah. Coolios.
Wait, you only tutor chemistry, or can you do biology?
Do tutor bio and chem and Oracle.
Oh, okay.
Yeah, because I do MCAT and DAT tutoring.
Oh.
And anatomy, but that's just because I took these classes. So if I've taken some of these classes and I feel comfortable, then I tutor them.
Okay.
But if it's like Mendelian genetics with epistasis, then I don't want to touch that.
Okay, yeah, you're not gonna want it. You're not
Yeah, I
gonna
don't want to touch it. But if it's molecular genetics, where they're talking about like gene expressions and yeah, that type of stuff, then I'm okay. Transcription, translation stuff, I'm okay. But if it involves drastic probability math, you're better off at someone else with someone else.
Okay.
Yeah, Sounds good. All
I'll
right.
probably text you. We can probably keep this time. Wednesday.
Sure. I just put it in as recurring on our on my Google Calendar. I don't know if it got sent to you.
Okay.
Yeah, but just let me know like a couple days in advance if you can't make it or if you need to change it.
Okay.
Yeah,
Thanks.
because I'll just reserve this time slot for you.
Okay.
Okie dokies.
All
All
right.
right. Have a nice week. See ya. Bye.